A few months ago, I came across this thing called stenography. It's basically a method of typing where you press all the letters in a word at the same time instead of pressing them individually. That makes it fast, really fast, and I want to be fast. Stenography is mainly used in courtrooms to transcribe everything. There are dedicated machines to type with stenography, but they're a bit expensive. But there is a solution for this. Some really smart people coded a program that lets you type with stenography on your very own keyboard. And since I want to be fast, I'm gonna make my own keyboard from scratch with no prior knowledge. This is gonna be fun. Step 1. Layout. The first thing I needed to come up with was how many keys I wanted. A stenograph keyboard only requires 22 keys to function properly. This is because the keys on the keyboard represent the sounds that make up the word. For example, to spell the word cat, you would press K, A, and T. Giving my keyboard 22 keys would be sufficient, but I wanted a little more room to play around, so I settled on a 30-key split design with each side of the keyboard having 2 rows of 6 keys, then a 3-key thumb cluster. Wow! Settling on the keyboard design was good, but the question remained, how do I turn this into an actual keyboard? Well, after searching the internet for keyboard guides, I came across Flatfoot Fox's guide, which uses this thing called Ergogen? Wait. Hold on. First, we gotta understand how keyboards actually work. Step 1.5. How keyboards work. A full-sized keyboard has 109 keys. You could just connect every single key with its own wire to the MCU, or microcontroller, not to be confused with the model. But that would require way too many wires and be really inefficient. To solve this issue, keyboards use this thing called a keyboard matrix. So, you know how in chess, each spot on the grid has its own name, like knight to c3 or whatever? A keyboard actually works in a really similar way. A keyboard matrix is made up of columns and rows of wires, but they don't actually make any physical contact with each other. With this setup, you have 9 intersections. Now, at each intersection, you're going to place a switch that, when you press it, it connects the corresponding row and column. So now, if you power this column and press this key, that row also gets powered. And with that information, the computer can tell what key you're pressing. And that is how keyboard matrices work. Okay. Never mind. Okay, back to Ergogen. Ergogen is a set of scripts designed to turn text files into keyboard design files. It's a really powerful tool to help you design keyboard PCBs or printed circuit boards. The first thing I needed to do was assign where I wanted my keys to be. Then I referenced those points to create the outline of the keyboard. Using all that, I added a new PCB section, and under that, added all the required components. The most important part was defining the MCU pins and making sure that each component was correctly hooked up to the chip. But when all that was finally done, all I had to do was click generate. What? Okay, let's try that again. All I had to do was set up Ergogen to run locally, then import the missing footprints, then run this command so that I could open up the file with KiCad. Step 2. Pain. The last thing I needed to do was routing and connecting all the wires up. So, Step 3. Actually making it. Now that I was done designing it, all I had to do was export it to a PCB manufacturer and wait.
2,000 years later.
Okay, so I have the PCBs here with me now. They look super cool. Look at that. Look at that. And now I just gotta do some soldering and get all the components on it. One side is done. Other side is also done. Switches. Keycaps. Random cable. Switches again. Keyboard! I had finally finished making my keyboard, but that was actually just the easy part. Now I gotta code firmware so it actually works. Yeah, no, I'm doing that later.